Hey, I'm Andrew Birch, and I recently spoke at the DDDBrisbane conference back in the start of December. And I presented a session called Becoming a One-Person DevOps Team with Visual Studio Team Services. But I had some technical difficulties at that presentation, and not all of my demos displayed correctly. So I'm decided to record this video as a way so that I can show you what I really wanted to communicate on the day, and that is how Visual Studio Team Services can basically allow you to set up a DevOps process without having to have a lot of infrastructure or people involved. So that's what this is. So I was originally going to put the video of the presentation up, but I'm basically re-recording it here so that I can show you a working version of it. So we'll get started. So essentially, with Visual Studio Team Services, it was recently renamed from Visual Studio Online, which is why I've crossed it out. There is a number of different sections in this product that allows you to manage the different various parts of the application development lifecycle. So there's a work section for basically work tracking and planning and everything. There's a code section for basically it's just a code repository. It's what you would think of as TFS. Traditionally, we can also host Git repositories now. There's an entire build section for basically building code. And then there's a test section for all of the testing tools and etc. There's also currently a release section, but we're not going to go into that because this isn't applicable to what I'm going to be talking about, which is mobile applications. So I graduated university about 18 months ago. I work for a large Australian organisation. The employer I work for mainly develops web and desktop applications, mainly web now, less so desktop. And being a big organization, they normally deliver products using the waterfall methodology. So the project I'm on, which is the mobile app project, it's pretty new. It's less than 3 years old. But when we started, our organization has a lot of infrastructure and processes and teams and stuff that have systems set up for quickly deploying websites, etc. But they didn't have anything suitable for mobile, both from technological limitations, the fact that you need Macintosh computers connected up to your network to be able to build iOS apps, for example, but also skill limitations. Mobile apps are something they've never done before. We had people who were very good at developing website deployment processes and build processes, but less so for mobile. So for our team, we decided to roll our own processes, our own infrastructure, everything that was just suited to us. We work in an Agile way, which is what the rest of the organization is now doing. So that's a bit about my background. When I talk about a DevOps team, because there may be specific meanings that you might know for DevOps, in this presentation, I'm talking about it in the fact of I am the person who looks after the tools that the other team members use to do their work. So as I said, that was work management, source control, build tools, and test tools. And also, I try to set up the tools and write the documentation and do everything I can to encourage people to work with the tools in the way they're designed to, because when you work with the tools work for you and you get the benefits from them. If you don't, what tends to happen is your tools, they just won't quite work properly for you. They won't quite give you the benefits that you are expecting of them if you don't work the way they're designed. So that's the other part of my job. So the common tools used today for various parts of the software development lifecycle, you've got Jira for Agile work management, so you've got the boards and everything like that. And then teams will often put their code up on GitHub. They'll use something like Jenkins or TeamCity for the actual building of the app. And then they'll use possibly something like HP, Quality Center, for the testing and the defect tracking. But what if you could have everything in one product? And that's what I want to talk about today with Visual Studio Team Services. So as I said before, Visual Studio Team Services, and by the way, this also applies to the on-premise version of this, which is TFS. I'm talking about the cloud-developed one because it's really quick and easy to use the cloud one. Although, if you can't use the cloud one for whatever reason, there is internal on-premise versions available, which is TFS. But it basically covers work, code, build, and test. And it also is released, but again, I'm not talking about that today, only because it doesn't apply to mobile apps. So Visual Studio Team Services is updated approximately every 3 weeks. And what they tend to do is they deploy features to Visual Studio Team Services, and then because they only update TFS, the on-premise version, once a quarter approximately, they will essentially take any of the features that they've done that are ready for deployment on premises and roll them up into the updates that get sent out quarterly. So because Visual Studio Team Services is getting features every 3 weeks, you're often getting features before they come from TFS. It has a couple of limitations that TFS can do, but Visual Studio Team Services can't do. And it's mainly around reporting some of the advanced customization and some of the integration with other products. They've started work on some of the more advanced customization scenarios. So in December, they started to roll out the custom work item stuff. So there's that. Before I go into the product, I should probably talk about licensing because that's an important part of this for many people. So everything I'll demo today will be free if you have a team of under 5 people, and that's for commercial purposes too. It's not just free for non-profit use, etc. It's free for commercial use as long as your team is under 5 people. The testing component I'll talk about costs extra, but we'll talk about that later. If you start to add more people, it starts to get more expensive. So the costs are listed on the slide here. You can have as many non-technical stakeholders as you want, though. If they only need access to some of the basic tools, such as viewing the board, some basic adding to the board, not the ability to look at the code or the build or the test or anything like that, you can add as many people as you want to that section for free. So it's really only people that are on the team and need to use the product for coding or testing or building or advanced work management that need to actually be counted as part of the paid users. So I developed an app to use as an example. It's called Alphanumeric Oz. I'll show you quickly what it looks like. I've also set up a couple of workstations here, workspaces here. Virtual desktops, as Microsoft calls them. So the first one is the virtual desktop of the DevOps team person. So that would be the equivalent of my computer. The second one would be the product owner or the management team. This is the equivalent of their computer. The third one is the equivalent of the developer's computer. And the fourth one is the equivalent of the tester's computer. So I'll go to the dev's computer and quickly show you this app. So I'll run it here, and this is the app. It's not finished at the moment because if you click on something, it doesn't work. But that's actually going to be the point of today's demo. So yeah, that's it. It runs on the phone as well, and it also runs on an iPhone and an Android phone as well. So it's a cross-platform app. So I can go across here and run it on the phone, and there it is on the phone. So yeah, that's the sample app. So I'll go back here and I'll go back to the presentation. So the first section I want to talk about is the work section. As I was saying before, Visual Studio Team Services is not just a tool that's used for technical team members, as TFS was in the past, because often people think of TFS as that's what the tech people use. The rest of us, we use another tool, but it's not. It's designed to be for everything. And so there are certain sections that are very appropriate for non-technical people to be using, and that's the work section primarily, which I'm going to talk about right now. And if you use this stuff correctly, it feeds into the developer's view when they decide to get around to coding it. It comes up with the tasks they need to perform and stuff right in Visual Studio. So we'll start off here by going to the product manager's computer. And as you can see here, this is the backlog. So the backlog basically has everything that needs to be worked on. It's all the features. You just keep adding stuff to the backlog in an Agile environment. And so basically, at the moment, in the last sprint, we got a bunch of work done. So the app to where it is now, this is what got work done. So I built a data retrieval service. I built some of the shared logic for the home screen, and then I built each of the screens for the 4 different platforms that I support. They were the stories. So if I go and have a look at the stories, normally you would fill these up with the descriptions and acceptance criteria. I haven't done that because this isn't a real project, but in reality, this is where you put all the information that the team needs to be able to complete the piece of work, and a story wouldn't be set to approved unless this was done. So that was what was done last sprint, but we'll go back to the backlog. So this is what's still left to do, and theoretically, this would be a much longer list, but as this is a demo, this is it. So we as a team would have an Agile planning session, and what this would mean was we'd go across to the board and we'd say, yep, this is all the work we're going to do this sprint. And so we would grab each of these and drag them across to committed, saying, yeah, we're definitely going to commit to this. So I'll drag them all across. They are listed in the priority order. So theoretically, you would do the things at the top first and then move your way down the list. For today's demo, we might do them in a different order, but that's how it works. So we've done that, and the other thing we would do is we'll go back to the backlog. Is we're going to drag each of these, I can select them all at once, and we'll drag them into the current sprint. So now we know that these are being committed to be worked on in sprint 2. So they've all updated. So now, as a developer, I'm going to go back to here, refresh the page. There we go. We are now ready to start making tasks. So you would probably do this at a planning session or just after a planning session. Each of these screens, by the way, has 2 views. So the backlog and the board show the same data. They just show them in a different format. So for adding things, and reordering, it's generally easier to use the backlog view. But for displaying information, say at stand up or something, the board view is much more appropriate because it gives you a visual version of what's actually happening. So for each of these stories, I am just going to add some tasks. So I'm going to do that right here. You can click the plus beside task to add stuff to it. The internet's a bit slow here tonight, but it should at least work. So the first one will be the create the root details view model. I'll assign that to me. It's in the current sprint, and we'll save it. Okay, we'll make another one, and we'll just keep making it. So I've got about 6 of these to make. So for the iOS one, create the iOS view. And finally, this one. Okay, so I've created all my tasks. So if I go back here to the backlog now, one of the other things we can see is there's a bunch of charts and stuff. This is called the velocity chart. This is pretty awesome because it shows you how much you did last sprint and how much you're going to be committing to for the next sprint. So the idea is you find a number which you can actually get done each sprint, and you try to then base all your future sprints on that much work. You get better at it over time. So at the moment, we've got approximately the same amount of work last sprint as we do this sprint, which is great. So now that's all done. If we go back to the slides, we're now up to the code section. So as I mentioned before, Visual Studio Team Services allows you to either use the older Team Foundation version control, which is centralized source control, or you can use the newer Git source control, which is distributed source control. Basically, the differences are Team Foundation version control. Essentially, there's a main master copy of it on one server, and so everybody tries to check into that one server. You tend not to have multiple repositories. While Git, the idea is you check into your repository and then you sync it up with a master repository, so it's more distributed. With a recent update to Visual Studio 2015, which is update 1, team projects can now have TFVC and Git repositories inside them, so you can have both. So previously, what this meant was once you picked a source control type for a team project, you could not change it. So that would be fine for most projects, but the traditional one was you had a TFVC project. It's always been like that, and you wanted to maybe try your hand at Git. If you wanted to do a Git repository, you'd have to start a completely new team project. All your history would be lost. But this allows you to set up a Git repository in there as well and just, dip your toes in the water and see how things go. So that's what that's for. It's basically, why don't we have both? So they did. So now we're going to go back to the developer's view on this. And we're going to actually do a little bit of coding. So I'll just close that. So I've prepared all these changes in advance. So I'm just going to quickly just do them. Essentially just involves adding files to a project. So start with the core project. I need to add some files. So Android, so basically I just had a view model to add there. For Android, I've got a couple of files to add. With the Android view, I've got the layouts that are applicable to that Android view. And it's the same across all the other platforms, really. So for iOS, got a view. For Windows 8.1, there's a view. And for Windows Phone 8.1, there's a view. And there's some tests I need to add as well that I wrote. And the one other thing I need to do is I need to make a quick change to one of the files and just uncomment this line here. That means that when somebody clicks on one of the items, it actually runs some code, since that's now available, since the code's now there. So now if we go to the Team Explorer and we click over here to Changes, we'll notice now that all of the files that we've made changes to are now here. So they're ready to be checked in. So we will come back to this in a minute. I'm now going to slip back to my computer, the build manager, and I want to have a look and show you some of the build definitions that we've been working on. In Team Foundation, in Visual Studio Team Services in 2015, they completely redid the build stuff, which was awesome. So there's a new build agent in TFS and Visual Studio Team Services. Instead of being something that ran only on Windows, it now runs cross-platform. So that's pretty awesome. It's a small set of executables on Windows. On Mac, it's a Node.js app that you can install using the Node Package Manager. And essentially, it sits on your computer or on your build server and listens to a build queue that's up on the TFS or Visual Studio Team Services server. And the agent, when triggered, will execute a build definition. And a build definition is something that you create up on the TFS or VSTS server, and it's made up of tasks. On Windows, tasks are generally PowerShell scripts or Node.js JavaScript modules. And on Mac OS X and Linux, they're always just JavaScript Node.js modules. At the moment, if you want, you can then go and write your own custom tasks and basically sell them on the Visual Studio Marketplace if you want, because there's only a limited set in there at the moment, although the set that do come in there are very, very good. So I've created these ahead of time so that there's less typing, but if I click Edit, I can show you the details of all of them and what they exactly do. So essentially, a build definition is just a list of tasks, which they also call build steps. And it just follows through each of these build steps one at a time. And if they all succeed, then the build is classified as successful. And if one of them fails, it will then generally call the build a failure. And usually it will stop on that step unless you configure it not to. So this is a cross-platform app, and so we'll have a look here, and I'll show you the platform builds for each of the definitions for each of the platform builds. So firstly, we've got iOS. So to build iOS, you just need to know the solution file name. So that's just alphanumeric O's. You give it a configuration that's set as a variable. So anything that has a $sign with a couple of with words in brackets, they're variables that you can set on the variables tab, as well as there's also some pre-built-in variables. So that's that. We'll come back to that in a minute. In this case, we want to build for the iOS simulator because I don't have an Apple account to build a real app for the phone on, because you need provisioning profiles, etc. But normally you wouldn't build for the simulator. So that's step one. It basically builds the iOS solution. And then step two is I'm telling it to grab the contents. So it grabs the contents of this folder. So it's a long path. It's basically the .app folder, so that you can, this is what we'll be able to run on the simulator later. But essentially, it looks in the build sources directory. So build.sources directory is one of those pre-built-in variables that comes with the build agent. It essentially just says, look in the folder where it downloaded the source code to, because when it builds it, it creates a bin folder and etc. That's what ends up when you build an iOS project. I want to copy everything that's inside of that .app folder. This is a mini-match pattern. You can have a look on the internet to see the syntax for mini-match patterns. Basically, this just says all the subfolders and files within all those subfolders within this root folder here. I want this to be called alphanumeric as iOS.app. As you will be able to see later, this is what will work on the simulator, and I want it to copy up to my VSTS or TFS server. So that's the iOS build. So we'll queue that build. And it will now look for a build agent. So there it is, it's building. It's first step is preparing the workspace, which basically means it's grabbing the latest version of all the files. So we'll just let that happen. And while that's happening, I actually want to go back and show you the rest of the tabs for the build definition. These generally stay pretty standard across all of my build definitions. So this tab allows you to do a couple of things. For example, create work items if the build fails. And this one allows you to build multiple different configurations. So if you want to build, say, both a simulator and a device version of an iOS package, you could do this, and you can actually pass in multiple build configurations. This is basically saying that we're going to get it from our Git repository, from the master branch. Here's our variables. So some of the variables that come. So basically, I'm building debug builds. The reason I'm doing that again is because the debug builds will all run on the iOS simulator, and I'm using the free developer certificate. I don't have an Apple account, as I said, so I can't use distribution certificates. Now this tab we'll want to turn on in a sec. And this basically means that whenever we check in or commit a change, it will run a build, which is exactly what we want. So we'll do that. The only real thing to note here is we want it to build from the agent queue. So there's various agent queues. One of them is called hosted. That will build on Microsoft's infrastructure. We want to use the other one which I made, which is just called default, because they don't have Macs on their infrastructure, so it won't work. And then the other two tabs, this is just about how long do you want assets to be stored on the VSTS server. VSTS doesn't seem to let me change this one, so basically it will delete everything after 30 days, which is fair enough because it is free. And finally, this allows you to see the change sets to your build definition. So if you make a change to your build definition and you want to find out the difference between it, you can do diffs on it. You can undo changes that didn't work. It's very good. It allows you to keep a history of that. So I'll save this. There we go. And you can see it just added my change set in here. So we'll go back to the build and see if it's built yet. Still running. Looks like it's still downloading a copy of this. It's interesting, it's taking a while. Anyway, we'll go back and we'll have a look at the other two platforms while we're waiting. So the Android one has a few more steps because of the various things you need to do to build an Android app. The first thing is, for an Android app for Xamarin, is you need to know the project file rather than the solution file. I'm not exactly sure why that's the case, but that's just what they do, so that's what you have to supply. The second piece here is the target. Now, basically you need to type in the words package for Android, otherwise it will build your solution, or your Android project, but it won't make a .apk file, so you won't be able to actually load it onto anything. So you just need to put the words package for Android in there exactly like that, and it will work. It's going to pop the contents of the build into the staging directory / build configuration folder. And finally, the output directory is where it's going to put the contents of the build once it's finished. So we're just popping that in the stage directory under the build configuration variable name. So whatever the build configuration is, that's what the folder will be called. Our JDK needs to be x86 because that's what Xamarin wants, and they use the 32-bit one and not the 64-bit one. So we'll go down to MS Build. Okay, so for MS Build, we need to build the unit tests project. Again, we're just leaving the default values for the build configuration and build platform. And we want the copy of the test build to be output into this test assembly directory in the staging directory. We also want it to be built with MS Build 14, which is the latest version, and on x86. We then want it to run these unit tests. So just where we put the assembly from the last MS Build, that's where it's going to locate it in there. And the assembly will be called alphanumeric.unittest.ell. So that's it. We're going to also make sure that it's Visual Studio 2015, so otherwise this will fail, because that's what we've got installed on the build server, is Visual Studio 2015. Next up is Android signing. So anybody who's built Android apps before knows that they need to be signed and zip aligned before they'll be able to be put on the store. And so this is what this will do. So the APK files for signing and zip aligning are located in this folder here, which is what we selected as the output directory here on the first build task. We want to sign the APK. I've put the key store file on my C drive. The password here, I've used a variable. This isn't actually the password. And the reason is that if I type the password in here, as you can see, it's clear text. If I use a variable, variables can be made secret so that no one can actually see them. So that's why the passwords are going to be like that. The alias is just demo. This is just a demo key store I made. And the jar signer arguments are the default, so I leave those alone because they work. And finally, I'm going to zip align it, and it just needs to know the location for where zip align is, which is in the default directory where Microsoft installs the Android tools when you install Visual Studio 2015 and pick that you want to do Android development. The file name has spaces in it because program files has spaces, but this didn't take very well the spaces, and quotes didn't work properly and everything, so I just went to the old MS-DOS style in Windows 95 when you needed to refer to a long file name, one that was more than 8.3 characters. In a DOS prompt, you could use this thing where you put the title character. So that's what I did here. And finally, we're going to copy the contents. Well, not quite the contents. We're going to copy all the APK files that are in this bin directory that we basically created, the output directory. We're going to copy them up there in an artifact name called basically the build configuration. You've decided -package, and I'm going to pop them up on the VSTS server. So we'll go across to here. These are all the same options now as when we looked at iOS, so we'll just do the same thing. So this time, so there's the password, by the way, and it's secret. So even if I was to untick that, it clears it out. So you can never actually find out what the password is unless you're the one who typed it in. We're building a release package this time because I don't have any of the distribution certificate issues that I do when I build iOS ones. I also want this to build on each check-in, so we'll tick that. Again, I wanted to use this queue because I don't like, even though you can use a host queue, for this case I've still got my own local build server, so I'm just going to pick that, and the retention history the same. So look at that. Now we'll have a look at Windows Phone 8 and 8.1. So a few less build steps than the Android one for this one, but again it's all pretty similar. So the solution, so just like iOS, you just need to put the name of the solution file, and again, build platform, build configuration variables that we set on the variables tab, so we just label that. Again, needs to be x86, not x64. If we go to test, we basically just want it to grab all the test things out of the directory, out of anything basically that's named test. We want code coverage, so that'll tell us how much of our code is unit tested, which is nice. Again, we need to run with the 2015 version because that's what I've got installed on my build server. That's all there. And because of the way this build configuration was set up, it actually will build both Windows 8.0 phone packages and Windows 8.1 Apex packages. So we basically just need to copy two lots of file types up to the server. So the first one goes through and it'll just grab the ZAP files out of this folder and pop them up on the VSTS server. And this one will look in this folder and again just grabs the Apex upload file and puts it up on the VSTS server as well. And we'll just go through again. So it's going to build from the repository. The variables are just debug and any CPU, which is the default. We want this to build every check-in. And this is all the same. Don't need to change that. So we'll save that. So go back now and have a look at our iOS build. And it has completed successfully. So that's awesome. So you can have a look here. We don't run at the moment, we can't run unit tests on iOS because there's no build steps in there that run unit tests, which is what you need to be running on the Mac. Hopefully at some point they will add that ability. A third party could write it, so it may just be a matter of a third party writing it and grabbing it from the Visual Studio Marketplace. But for now, you can't run the unit tests there. So otherwise, you'd see test results and stuff. So we go to artifacts here. There is our package. So I'm going to go back to Visual Studio now. So we're back to being the developer. And we're going to check our changes in. So, or commit them, I should say. So we're adding root details screen. We'll commit this. And then we'll sync it up with the server. There we go. So if I go back to the DevOps computer, I should see, there they are. So all three of them are currently queued at the moment. So some of them will be running on the Windows build server, and some will be running on the Macintosh build server, which is why there's two running at a time here, because two different computers. It knows which ones to send to because essentially each build task has a list of essentially requirements, and each build server has a list of capabilities. and it basically matches it up. So it finds a computer in the queue that matches all the capabilities that each of the builds need, and it will send it off to the right place. So if I go to the Android one here, we can watch it build. So it's built successfully. It's currently running the tests. And that's okay, so the test has failed. So this is good. I deliberately made this fail because I wanted to show you that a test failed. And if we have a look here, it's this M7 road count test that failed. So actually we'll go back to the main results. Here we go. So yeah, one test failed, and it's the M7 road count. That is also going to fail for the Windows Phone build and Windows 8.1 build when that goes up, I'm sure. So we'll just go back to that. So it's now running tests as well. Yeah, same failure. So that's good. It's working as expected. The iOS one will succeed, as I said, because there's no tests running on that one. Yeah, and it succeeded. It's currently copying them up to the build server. So what we need to do now is go back to the developer and get them to fix the bug, which should be pretty simple because the bug is not hard, thankfully. So we'll go to the Solution Explorer and we will open up the models, I think. No, it's the service. Yeah, here it is. So this service I wrote here, essentially, because I don't actually want a real service. I just wanted a mock one. So I've basically mocked it up. And what I've done is I've commented out one of the roads. So if I go here and I just uncomment this, no. But what I also will do before that is I'm going to go raise a bug to track this. So before I check it in, I need to raise a bug to track it against. So if I go back here, now the DevOps person probably wouldn't normally do this, but anybody can access this tab and raise a bug. So I'm going to go here and I'm going to create a bug. And it's going to give me all the details for the repo. Well, it's putting the repo steps in here. Basically, it's running a unit test as the repo steps. So I'll just modify this quickly. I will assign this to me, the new bug. So we'll save it. And now I'm also going to work on the bug. So I'm going to commit the bug. And it's going to go into the current sprint, so that's good. And now we'll close it. So if I go back to now as a developer, I can now check in against this bug. So the bug, which I'll go back here. Actually, no, as a developer, I can check this out. So if I go to the sprint, there's the bug. That's bug 132. Fixing the bug in root Genesis service that missed M7 tunnel. So I'll commit that and I'll sync it up to VSTS. I'll go back to my DevOps computer now. I should have builds running again. Now, this time they should all succeed, so we'll just give them a few secs. But as you can see, this is all automatic now. So once I've set all this up and I've set it to be continuous integration, every time I'm checking in now, I'm getting bug checking. Basically, it's running unit tests and it's making sure my code is bug free. So the iOS one, of course, it doesn't check, so that's working fine. We'll go to the Windows Phone 8 one. Just check that one out. So it's running tests at the moment. Good, the test passed this time. So now it's uploading the contents of the packages. And we'll go to Android. It's still waiting to run. So we can actually watch it here. Each agent at the moment can only run one build at a time. You can actually put multiple agents on one computer. Here we go, it's getting ready to run it. Here we go. So it's grabbing the latest code. It's running the build. This takes a couple of minutes to do the whole process normally. Cool, it's building the unit tests. Now it's running the unit tests. All the unit tests are passed. Now it's signing the Android packages. And finally, it's copying those Android packages up to the VSTS server. So this build will be working too. So looks like we've got 3 greens, which is awesome. So yeah, this is basically the build working. So now we're able to move onto the next part. I can even actually show you while this is going. I can show you this working on an iOS simulator to show you it is cross-platform. So we'll just, there we go, it's a little slow. Just refresh this. Go to iOS. So we'll grab the latest build. We'll download the artifacts to the computer I'm working on here, this Mac. So it's currently downloading at the moment. This should take a minute or two. I've only got ADSL 2, so I don't have extremely fast cable internet. So downloads aren't super quick. But it'll only take a minute or two. There we go. So if I have a look in my downloads folder now, I can just extract it. Which on the Mac will just pop the folder in to the right location. There we are. So there's my simulator. So if I go back to the terminal and I run this command, it'll now install the app into the simulator where I can run it and show you it working. It's a little slow to load, but there it is. So there's my app, and I can click on any of the routes, and it'll show me the roads that are on that route, which is pretty awesome. So, actually, we'll go back to the slides. I'll move on to testing. So, VSTS allows you to do testing. Now, as I mentioned earlier, this is the one part that requires money, and it's kind of expensive. It's about $66 a month per person. People that want to run tests technically don't need to pay this. They can do that with just the basic plan, which is free for the first 5 people, and then between $5 to $10 a month for any more people than that. But if you want to actually create all the test plans and suites and stuff, and do any management type stuff, or have access to the Microsoft Test Manager software, you do need to pay the $60 a month. And the reason why it's so much is it gives you access to Visual Studio Test Professional 2015, which has Test Manager in it. So it's recommended, if you can afford it, to actually buy this, because the experience is a lot nicer. But if you just want to do some basic test execution, you don't have to pay. But to write those tests to be executed, somebody else would have to pay for their account. So yes, Microsoft Test Manager is what we're going to use here. So now we're going to go to the tester's computer. I'll just refresh here. So we've got a test already here that we can run. And as you can see here, I've already added this. So basically, I'm just doing this step, which is basically just navigating. So if I double click that, I've already written some steps. So it's open the app up, click on a route and verify that the correct routes are listed. So this is what the test will run. And so what I'll do now is I'm going to assign this to the current build. So I'm going to assign these testers to me. So that's all good. So we don't need to change that. But I'm actually going to go here to track, assign build, and I want the latest build to be assigned to this test plan. So yeah, it's assigned. So now we're ready to go to the test. I'm going to test the Windows Phone first. So here's the other thing you might notice. For one script here, there's actually 4 to run here, and that's because you can set up configuration. So instead of having to write separate scripts for every single platform you want to test, if they're the same steps, you can just set the different configurations here on the Organize tab. So you set this up. So I've got these configurations set up. And then you can assign scripts to configurations. So I've assigned this script to work on all platforms. So therefore I can, I don't have to worry about writing the script multiple times. It's set up for me. So I'm just going to run a script here on Windows Phone 8.1. I am going to switch the developer's computer to actually run it because I've got the emulator open there, but there we go. So I'm going to run it. So I'll start the test. So I'll quickly what I'm actually going to do is just go back here. I'm just going to drag this simulator over to the tester's computer so I can run it. There we go. So it's like the tester opened it. Okay, so now I can run this. So yes, that one works. I click M1. I get a list of route details. That's good. That works. And the following routes should be displayed: Bruce Highway, Gympie Arterial Road, Gateway Motorway, Super Motorway. So that works. So that test runs successfully. So I can save and close. Cool. Now I want to run the Windows 8.1 app. So again, I'll do this on the developer's computer. I'm just going to run on a local machine here. It's just loading. There it is. And I'm also going to put that on the tester's computer. Okay, cool. So now if I go back into Microsoft Test Manager, I'm going to run this on Windows 8.1. Let's start the test and we'll do the same thing again. So displays a list of routes. That's good. Tap the M1 route. Oh, that's odd. Nothing's appearing. There seems to be items there, but the text isn't appearing. So we'll fail this step. Well, actually, we'll pass that step. It's this one. There's no routes. So we'll fail this step. Routes did not appear. And so what I'm going to do is I'm going to raise a bug. So the awesome thing here is it puts the repo steps in and the comments that I wrote and everything like that. So route names, road names missing from route details. Assign that to me. And I'm going to put that into the current sprint. And we'll save that. And it tells you what build it was found in. And that's it. So now and we're going to change the state of here to committed because I'm actually going to work on it. So save and close. Save and close. So as you can see here, there's a failed script. So that's a shame, but we can fix it. So now we're going to go back to the developer's computer and we'll fix this. So the bug here was that for the Windows 8.1 project, if I go into the root view, just move that out of the way and I'll just go to the XAML because that'll be easier to show you once this loads. There we go. I forgot to put the Eon name. That's why it wasn't working. So just check that that's everything. Okay, so we'll check that fixing. So again, we'll go here to changes. I'm going to use a query that I built. Oh no, actually I won't. I will just grab the root number, the bug number, which I can do from the developer's computer if I just refresh this screen. There it is there. And it is bug, should be 153, that's 133, yep, there's 133. So it's bug 133. Fixing bugs so that road names appear on Windows 8.1 root details screen. So we'll commit that up. We'll sync that. Cool. So I am now going to go back to the tester's computer. And I'm going to go here. Actually, firstly though, I have to wait for these builds to finish. So we'll go here and we'll have a look at the builds. So 3 more builds running. So we'll give these a few minutes. Again, these should passed just fine. But we just need this build here in particular to pass. And it's still waiting for an agent to run. Let's see how the others are going. They're still going. Builds are pretty quick. There we go. So it's up to the final stage of copying the file up. The builds are pretty quick once you've done them a couple of times, because all the files will have downloaded, and so it'll just be a case of just grabbing what's the difference between the last change set or the last commit and the latest commit. So still going. Still going. There we go. So it's finished. Cool, the Android one succeeded. Which is fine, because we didn't really make any changes to the Android project anyway, so if it hadn't have succeeded, I would have been a bit concerned. Now the Windows 8.1 and Phone 8.1 build is going. It's running the unit tests, which should still pass, because we didn't make any code changes. Just some XAML changes. Cool, nearly done. There we go. So it's finished. So now I can go back to the tester's computer, and I'm going to refresh this page, and there should be new builds that I can pick to assign to. So we need to filter out here. For some reason it's picking iOS builds. We want it to filter for Windows Phone builds. There we go, and there's our latest build. So if I go to recommended tests now, or go to related work items, and I compare it to the last one, it should show me, there we go. So it shows me the change sets that were done, and in this case, the bug. So now I know I can retest that bug. So I'm going to go here and run this test again. And of course, what we'll do is run this again on the local machine. And this time it should hopefully work. So drag that over to the tester's computer, and now we can run it. So the app works, yep. I'll tap the M1 root, yep. And I get a list of road names that are correct, so tick. So that test now passes. And I can now go and mark that bug as fixed. This is the other part. So I was mentioning before, so that was Microsoft Test Manager, but if you can't afford Microsoft Test Manager for everyone, this is the web view version of it. So as I said, you can run tests here. I can't actually edit or create them because this account doesn't have the test extension, test management extension, but you can still run these tests. So I could, for example, run the Android one here, and it pops up a similar looking. Let's try that again. I think the Edge pop-up browser is messing with this. There we go. So I can run a test here, for example, which I won't do. So we'll go back to the slides and just finish this off. So the demo I wanted to show to you today basically was that this stuff all works better together. By having your work items and stuff associated in the work section, you can then use that for when you build stuff, and those builds can then run into tests, and the tests can go back to the builds, and it all works nicely together. But if you already have a working solution elsewhere, you don't have to use everything together. It does work better together, but there's still some other integrations. And the one I'll show you right now is this last build definition that I created, and it's called Xamarin Android 2. So I'll run this. What this one is, how this one is different to the others, while that's building, is one section. It's the repository section, which is just loading. This is actually coming from GitHub. There you go. There you go. It's working now. I've uploaded a copy of part of this app onto GitHub, and I'm using VSTS build to build code that's sitting on a GitHub repository. So as you can see, there is some type of ability to mix services and stuff, and there's other different things you could use. You can use the code repository functionality to build, even if you're using Eclipse or IntelliJ, because there's plugins there that allow you to do that. You could use Xcode if you wanted to. There's lots of different connections to it. There's a whole set of things called service hooks, which allow other services to talk to VSTS. There's now extensions. So, and there's even an API if you want to go and write your own stuff. So there's plenty of stuff. So that's it. That's the presentation. I hope you enjoyed watching it. I do apologize if the audio quality wasn't perfect. But this is the presentation I wanted to fully deliver at DDDBrisbane, fully working, and now it is. So thank you very much for watching.